guys, this is lesson 2-6. You can find it on page 111 of your textbook. It's called Ratios and Proportions, but we're going to be doing something that I casually just call cross-multiplying. It's a great technique in algebra and extremely useful. I use it actually all the time in just everyday math. I'm actually going to start working some examples on page 115. Before that, you can look at the examples yourself that are worked out for you in the textbook. But let's look at a problem like number 9. It asks us to determine whether each pair of ratios are equivalent ratios. And so if I'm looking at these numbers, I can set them up and ask myself, are they equivalent? And a way that I will know that is if I do something called cross-multiplying. I am going to multiply something called the extremes, and I am going to multiply something called the means. So when I multiply the extremes here, I get 9 times 99, and that needs to equal, when I multiply the means here, which is 11 times 81. So I just sort of multiply in an x. So I'm going to do 9 times 99. I have my handy dandy calculator here. It is 891. And I want to know if that equals 11 times 81, which is 891. So yes, they do equal. And so these are equivalent ratios or equivalent expressions here. All right, let's look at one that doesn't work. Let's look at number 11. I have 8.4 over 9.2, and I want to know if that is equivalent to 8.8 over 9.6. So I'm just going to use my calculator to multiply 8.4 times 9.6 and see if that equals 9.2 times 8.8. So I'm going to let the calculator do most of the work here. 0.4 times 9.6 is 80.64. And does that equal 9.2 times 8.8? 80.96. No, it doesn't. So those are not equivalent. That's all there is to that. It's just an exercise in multiplying crosswise, however you want to say that, right? All right, so jumping down to number 15, then I start to solve some problems with this. And I have 3 over 8 equals 15 over a, and it says solve each proportion if necessary, round to the nearest hundredth. All right, so when I'm looking at this, I am going to multiply 3 times a. Okay, so it makes like an x, right? So 3 times a is 3a. Always put the equal sign. These absolutely must have equal sign. We are not talking about this problem. Don't let it confuse you. We are not trying to cancel. We're not trying to multiply, and we are actually doing things that have an equal sign in the middle, and that's important. Then we're going to do 8 times 15. I'm going to do that real quick here, and get 120. Okay, so 8 times 15 is 120. And then I'm going to just solve this. Divide by 3. A equals 40. Cool. All right, let me jump down to something that looks a little trickier. Let's try number 27. Okay, I have x minus 3 over 5 equals 6 over 10. This works the same way. We're just going to think about what's on the top of a fraction or the bottom of a fraction. Always think about that as something in parentheses. And so we're going to add a little extra step here. We have 10 times x minus 3. I'm going to do x minus 3 times 10. I just like to write it in this order. Equals 6 times 5 is 30. Okay, so this looks like a much more doable problem without the fractions, doesn't it? We're going to do 10 times x, which is 10x. And we're going to do 10 times negative 3, which is negative 30. We need to add 30 to get 10x equals 60. And divide by 10 to get x equals 6. Not so bad, right? We didn't have to round on that one either. Okay, let's jump down to number 37. Looks about as complicated as we're going to get on this page. We have 4v plus 7 over 15 equals 6v plus 2 over 10. This whole lesson is about multiplying from this top to this bottom. So we're going to do 10 times 4v plus 7. Again, it's my choice to put that 10 first, just because I like it on the outside of the parentheses. I like it to look like that. Then we're multiplying this 15 times this 6v plus 2. And so I'm going to use parentheses again. All right, I'm going to have to use the distributive property to clean this up. 10 times 4v is 40v, and 10 times 7 is 70. And then 15 times 6 is 90. 60 and 30 is 90v, and 15 times 2 is 30. Now, I can solve this. I'm going to, I like to pick something that looks like it's not going to give me negatives, but sometimes that's futile. Hang on. We've got plus 40 equals 90v, right? This canceled, and this became 40. Okay, so I am going to subtract 40v, and I get 40 equals 50v, and then I'm going to divide by 50, and I actually get 40 over 50, or 4/5 equals v, but I think it said we needed to round to the nearest hundredth, and so for divided by 5, we can give it a decimal if it really wants it, would be 0.8 equals v, and that's actually tenths. It comes out even at the tenths. If I really wanted to put it at hundredths, I'd have to put a 0. One last example, if I look at number 40, it's a word problem. It says at Piedmont High School, 3 out of 8 students are athletes. So we have 3 athletes for every 8 students. And if there are 1,280 students at the school, how many are not athletes? Okay, so there's a couple ways to think about this. The information they gave us actually tells us about athletes. So if I were to solve this, I would know how many athletes there were in the student body. I actually want to know how many are not. I could solve that, and maybe I will do it 2 ways. Or I think I could say that if there are 3 athletes out of 8 students, there are 5 non-athletes out of 8 students. If I figure out this first one, I'm going to have to use subtraction, right? Because then I'm going to have athletes and I'll have to find non-athletes, but let's just do it for fun. I'm going to cross multiply. 3 times 1280 equals 8 times x. 3 times 1280 is 3840 equals 8x. Divide by 8. Divide that number by 8. I get 480 equals X. And in this case, I have 480 athletes. So I would need to do 1,280 students minus the 480 athletes gives me 800 non-athletes, because that's what it asked me. Yes, I know I just wrote some weird SS thing there. Let's go down here and solve this one. 5 times 1280 equals 8 times X. 5 times 1280 is 6,400. Divide that by 8. And I get 800 equals X. And in this case, it's 800 non-athletes. So you have to read the words, figure out what you want, figure out what they're asking, make it make sense, and then when you set up your ratios, make them match. Athletes over students, athletes over students, non-athletes over students, non-athletes over students. So it's not like when you're doing unit conversions and you're trying to get your units to cancel. In this case, you are doing equivalent situations, so you need to make sure that you have them match. If athletes are on the top here, then athletes are on the top here, like that. All right, try the homework problems, see how it goes for you.